So here we have intercept form of a quadratic. Y equals a times the quantity x minus p times the quantity x minus q. We know that the x-intercepts are negative p0 and negative q0. But why? Why is it like that? This explanation is going to be a lot faster and easier to understand than the vertex form one we just did. So let's look at it real quick. Well, where are the x-intercepts? The x-intercepts are going to happen when y is 0, right? Along the x-axis, y is 0. So that's the main point of what's going on here. Y has to be 0. So 0. The important thing for this one is a cannot be 0 because then the whole thing would be 0, and then we would just have y equals 0, and that's just a line. That is just the x-axis where y equals 0. So we know a can't be 0, but I have three things here multiplied together. So if 0 equals a times b times c, what do I know? I know that either one or all of these has to be 0. Because if a is 0, the whole thing's 0. If b is 0, the whole thing's 0. Same with c. In this case, we know it's not a, so we're just going to disregard that. So we know that either x minus p equals 0 or x minus q equals 0, or both. So in this case, how do I solve for x? I can add p to both sides. X equals p. How do I solve for x here? I can add q to both sides. So x equals q. And there you go. It's really as easy as that. When y is 0, x is q here, so that's q0, and here p0. So it's kind of the same thing as when we said for vertex form it's negative hk instead of hk, and here it looks like q0 and p0. So why do we say negative p and negative q here? That's because if you're just looking straight at the equation, this is a negative p and a negative q. So if I have, when I add that to the other side, it's going to be the opposite of it. So I'm going to add this to the other side, so it's going to be the opposite of it. So just like if it were x plus 3 and x minus 2, I would subtract over this 3 to make it 0, so it's going to be negative 3. It's the opposite of that. I would add over this 2 to make it 0, so it's going to be the opposite. That's why we say negative p and negative q here. Okay. So just real quick with this equation, I want to slide these around real fast. So p is going to be one of the roots, right? So if I move this around, it's going to slide one of the roots over there, and you'll see it's changing the vertex as well, obviously, because it has to stay symmetric. So as I slide that around, it changes one of the x-intercepts. You'll notice the other x-intercept is still 0. That's why it's kind of doing this funky dance here. I can do the exact same thing with the other one, or I could do it with both. So now I have two different ones. Okay. Now let's look at why is the x-coordinate of the vertex p plus q divided by 2. Well, the main idea here is that there's always symmetry here. When you're dealing with a parabola, quadratic, there's always symmetry. You'll see right here it's x equals 0, Symmetry means it's the same on this side as it is on that side. Why is there symmetry? That's because we're dealing with squares here. So if I have something like x squared equals 4, when I solve for that by taking the square root of both sides, I know that x can either be 2 or negative 2, because negative 2 times itself is 4, and 2 times itself is 4. So if x squared is 4, it has 2 answers. That's what's going on right here. We can go to 2 is 4, and negative 2 is 4. So whatever's going to happen on this side, the same thing is true for the negatives. That's because we're squaring. That's just what happens. That's a consequence of squaring. Then since we have symmetry, we know that it has to be exactly in the middle is where the vertex is, because this one goes off in this direction and this one goes off exactly the same way in that direction. So between any 2 points, it has to be exactly in the middle. So how do I find the middle of 2 points? Well, let's say I want to find the middle between 6 and 10. Well, I could write them all out, 6, 7, 8, 9, and 10, and say, okay, it's 2 this way and 2 this way. There's 8. Boom. Or you could have already known that in your head. But how do we do that mathematically? Let's take the average. That's what we're really doing here. It's not necessarily a formula P plus Q divided by 2. We're just taking the average. 16 divided by 2 is 8. That's how you can find the center of a group of numbers. If you just have 2, you take the average. Probably not so useful for 6 and 10 because you can do that in your head pretty quickly. But you know, if we had something like 102 plus 234, something like that, we'd get 336. That divided by 2 is 168. 168. That's the middle of those 2 numbers, right in the center. I've got, let's see, looks like 66 to go this direction and 66 to go this direction to get to 234. So right in the middle. That's why we do that. Once you have what's right in the middle, then you can use that to find what the y value is going to be. So in this case, let's flip it over so I don't have to move. Nice. Okay, in this case, the middle of, say, 4 and negative 2 is going to be 1, right? 1 right here. So then I can take 1 and plug it in with 4 and negative 2 as P and Q. Notice I switched the signs here because if it's 4 and negative 2, it has to be the opposite to go back in, just like when they came out. So I can take 1 and plug that on in. That equals negative 3 times 3 is negative 9, but that's a negative out front. So it's just positive 9. So I know now 1 and 9 is my vertex. Let's go check that. Looks right. 1 and 9. Perfect.